Hello, everyone. I'm Anna, and today I'm here with my colleague Björn. Hey, Björn, how's it going?
It's going great. How about you?
Very good, thank you. And I'm really looking forward to this one. Today, we'll be chatting with Björn about generative AI with your own data. And what I feel is really great about this topic is it basically only takes an introduction as short as the one that you'll be getting to grasp the basic concepts behind it. And that in turn will then get you ready to start figuring out how to employ generative AI on your own data for your use cases within your company. So I think we should just jump right in. So Björn, I think one thing that people would like to know probably is what are their options when they want to employ generative AI and their own data in combination?
Yeah, so if you look it up, there are two paradigms you just cannot get around. And the first one is fine-tuning, and the second one is something called Retrieval Augmented Generation, or RAG in short. And while it's great that you can combine both of them if you need to, if you just want to get started and looking for a solution, I would argue that RAG is probably the way to go.
Yep. Okay, so for those who are maybe not yet familiar with it, can you go a little bit into a description of what RAG is and like how people should imagine this?
Sure. So let's start with the very basic way you interact with the generative AI, like your ChatGPT. So the user will ask their question, and this is then called a prompt and sent to the generative AI, where a large language model under the hood will come up and produce a great answer, and that's returned back to the user. And if you have a longer chat, then your conversation is just included as part of the prompt. So the LLM has access to all of that and produce a context-sensitive answer. Now, if we want to talk about RAG, there's just this one more step that's introduced in between. And this is, you take the user prompt and then you're doing a retrieval on your own data, on relevant context information. And you find out what in particular is relevant to this very prompt, to this question. And from this data, you then build a contextualized prompt, including your data. You send that to the LLM, and now you can get back an answer that considers your own data, that's contextualized and probably more useful to the user.
Nice. So how does that compare to large language model fine-tuning?
Yeah, so for RAG, we just introduced this retrieval step to alter the system and make it more powerful. And fine-tuning would be you take the LLM and you modify this one. So then there's usually machine learning training going on. You have your own training data and you modify the LLM to better suit your needs. And as you can see in this image, it's perfectly fine to have both of them. You can combine them, but yeah, you can also do one of each of them on their own.
Nice. And what are notable differences to keep in mind, maybe?
Yeah, so I would say broadly speaking, RAG is the lightweight version. You don't need nearly as much compute, and this doesn't only make it cheaper, but it's also a lot faster to react on new data. So say your organization is producing data every day, every hour. It's perfectly fine to include this in the retrieval step of a RAG system, but you just cannot fine-tune a large language model so often. Apart from that, if you're building this contextualized prompt with the relevant bits of information, it's a lot easier for the language model to say, hey, I based my answer on this source in particular. So you give back the source links, something that's highly sought after. On the other hand, the fine-tuning is the heavyweight stuff. There are some things you just cannot really do with RAG. Let's say your language model is very capable of speaking English, but you have another language where it doesn't do so well. If you want to improve this, you're probably going to need fine-tuning. You just cannot get that done with RAG or like really teaching the model new behavior. Apart from that, sometimes there can be questions that just require lots and lots of context and background knowledge. And it's just not feasible to find all of that in the retrieval step. And then maybe your prompt would even get prohibitively large. So what you're doing is you're fine-tuning with that data, then it gets internalized. These billions of parameters of the large language model can be used to store that data in a way. And now your language model is able to include all of that when finding an answer to your prompt.
Nice. Yep. So basically, it's about knowing what to do when and knowing your situation and making a wise decision there.
Exactly.
Nice. So I think we are ready to learn a little bit about how RAG works internally. What is like the steps it goes through?
Sure. So what we're going to do now is, when we come back to our basic diagram from before, we will unpack this retrieval step here on top and look at what's happening. So the first thing you're doing is something, it's pre-processing. You do that well before a user interacts with the system. You could also do it in the background if you have changing data, but has nothing to do with the prompt being asked at that particular point in time. So you take your data and you put it into sensible chunks, like individual documents or something like that. And then you send each of those documents to an embedding model, a model that will then be able to produce a vector representation of your content. So you get a bunch of numbers that are mathematical representation of this document's meaning. And then you take these vectors and you store them in a vector store. That's just a database, and it does one thing well, and that's if you come up with a new vector, you can, you take a vector as a query, and you can ask the vector store, hey, please give me back the most similar documents to this query vector. And this is exactly what we are going to do when we're using the system then. So now we have this user, they ask their question, and the first thing we're doing is we're embedding this question with the very same embedding model we had before. And then we're taking, so now we also got a vector that corresponds to the meaning of the question. And then we're taking this vector and ask the vector store, please give me back similar documents. And these similar documents are then the perfect context information we want. We take our user question, combine it with these context documents, and this is then the contextualized prompt we want to send to the LLM, and it's able to generate this answer back under consideration of our data.
Nice. Yeah, I think we got the basic steps. And so next, I think we would like to know what sets this basic version of RAG apart from really successful RAG implementations, would you say?
Broadly speaking, it's all about understanding your own data, understanding your users, and then adapting to that, really thinking just about your use case and doing the right thing for that.
Nice. Yep, that makes sense. So I think we are ready for like a concrete example, and I think you have something for us.
Sure. So what you'll see online all the time are examples where you have a bunch of documents like your website or some transcripts, and you want to enable questions over that. And these examples are perfectly fine, but you see them everywhere. Yep. So let's have a little twist, pick something a little different, and let's talk about a shopping assistant where we want to recommend products we're selling to a user, and the user asks questions, and we say, hey, this could be a great fit for your needs.
Nice. So what additional tricks are we going to use then for the shopping assistant scenario?
Again, there are many things you can do, but I want to focus on an enrichment step, which we add before the indexing even. So we will take our documents, our data, in this case, the products from our catalog, and we will enrich them with some extra data. And in a minute, we'll see how that can be very useful. So let's say the user asks a question like this one. I'll go on a long flight. What products can you recommend? And let's also say we have something useful in our catalog here, like these compression socks.
Yep, we're getting old.
Well, maybe the flight is very, very long, and maybe they serve drinks. I would say they are useful for a flight. But anyway, this product here has a perfectly fine description, and it's really informative. However, it's really not at all similar to the question. So we can really see how this retrieval step, looking for similar embeddings, might fail us here. But there's an easy trick we can do, and this would be we ask an LLM, hey, what is this product useful for? Yeah. And then it can come back with something like these examples here, like about hiking and mountaineering and several sportive ones, or also something medicinal like prevention of deep vein thrombosis when traveling. And now we have something that's pretty similar to our question. And if we include this before we compute the meaning embedding, then we can really see how it's similar enough to the question and come back here. So, and it's not only for this particular question, of course. So maybe another user is looking for equipment to run a marathon, and the exact same enrichment will be helpful there. And in general, I think this idea is around for the document retrieval. And what people usually like to do is they ask, hey, which questions does this document or this snippet answer? And again, this is very useful for a RAG application like that. But in our case, it would probably be useless. It would come up with the same questions for each and every product, like what material is it made of? Is it available in multiple sizes? And so on. So, but just having this little twist and asking the model a different question, the one for the use cases, suddenly turns the same trick into something very useful for this scenario and something very powerful here.
Nice. Yep, that's actually a cool trick. I think people probably are still wondering, are there also problems with RAG? Something must be wrong with it.
Sure, there are problems. There are always problems. One thing we've already seen in the last example, I mean, we found a solution, but it's always this embedding retrieval. It works nicely, but it has its limitations. Yeah. And here we've seen a possibility to make it a lot more powerful. But what people will also do a lot is that they combine the embedding-based retrieval with keyword search, simply because the embedding retrieval isn't 100% perfect. And then something else you often have to consider is correctly chunking your data. In our case, we can assume that maybe the product descriptions already have the perfect size and we don't want to take them apart. But if you have long form texts, you may have to chunk them. And then you have to be really careful to retain the meaning, to retain the semantics there. And then finally, we've seen these other cases where we just would prefer fine-tuning, like incorporating this huge contextual information, which is just too much for the prompt, or teaching the model new behavior and so on. So these are definitely limitations of RAG, and often then the cases where you want to combine with fine-tuning.
Yep. Yeah, I think it's probably just about being aware of your situation and choosing the solution that fits your needs, actually.
Exactly, yeah.
Yeah. So I want to go a little bit further in a similar direction and ask, because I think one thing that is pretty high on the agenda of several companies, I think, is privacy concerns, probably. So what should people keep in mind with respect to RAG in that area, would you say?
Yeah, there are definitely a few things you have to be careful of. And in general, I would say the paradigm's just fine, especially like this vector store that can be hosted wherever you want it to be on your own premises. But then again, there are several places where we use a language model, like I've marked them here in blue. And first of all, you're sending your data to this language model to have it embedded, and you're also sending user interaction there. And then if you're using a language model via API from one of the big providers, that can be an issue. And in general, I still think it's a good idea to use those APIs because the models are very powerful, the prices are fair, I would say. But if privacy concerns are a problem here, then of course you cannot do it. The good news is, though, for each of these models we're using here, there are very powerful open source alternatives. So you absolutely can still build a RAG application with very high attention to privacy. However, you will just need to invest some extra work. You will need a lot more hardware on your premises, but the paradigm itself is compatible to all sorts of privacy concerns.
Yeah. Once you've pinpointed the points where you want to keep it within your own limits, then you can just adjust to that.
Exactly. Yeah.
Now that we know that this is actually all solvable, are there more ideas for people for things that they could do with RAG or problems that can be solved with RAG? Do you have some pointers for people?
Sure. It's very hard to come up with the best ideas. And I think, in fact, our viewers were probably those positioned best to do that. I mean, they know their data, they know their users, and then you can come up with the very best ideas. But to give you some, to give them some ideas and a place to get started, what's also popular is something where you're using your generative AI to accept natural language questions, but then you turn them into a database query, something like SQL, and so that you can answer with data stored in your database. Yep. And this is a conversion language models can do, but you can make it much easier and much more successful if you're building a RAG application. You're looking at the user question, and then you retrieve just the right parts of your database schema and some examples that are somewhat similar. And these examples would then be a natural language question together with the correct SQL query that answers that question. And if you pass these examples to the LLM, it's a lot easier for the LLM to come back with the correct SQL query for this user question. Same thing applies if you're having an internal API you want to use. And again, then to produce the examples and the accuracy of the language model producing the API call would just skyrocket compared to not having examples at all.
Interesting. Yeah. I think what we've seen is that building a basic RAG application can actually be pretty straightforward. At the same time, if you really want a great user experience and a really high accuracy, I think that's when it becomes important to really hit all the details and get every point of it right. Is that like a summary of basically the situation, you'd say?
Perfect. I mean, every time we build something like this, we learned a little new thing that in the end turned out to greatly improve the accuracy or the user experience.
Thank you very much, Björn, for this introduction into generative AI with your own data.
Thank you. It was a pleasure.
For me as well. Thanks. And thank you everyone for listening. And now we are actually curious. So what are the challenges that you are trying to solve or would be interested to solve with RAG and your own data? And what are maybe the problems or tricky aspects that you are facing? So if you would want to share those with us, that would be great. We would be very interested in hearing about this. And yeah. One other thing that I can mention is that if you would be interested in diving a bit deeper into this topic, is that Björn will actually soon have a blog post ready about the same or similar topic, and that will appear on the CID website in the near future, and so you can stay tuned for that. So thanks again, and thank you for listening, and bye-bye.
Thank you. Bye-bye.